to know what is beyond our world and among the stars. Our curiosity and determination has pushed us beyond our limits in an attempt to discover the great unknown. Many ancient people believed that the stars were simply affixed in a vast dome over the flat Earth. But in 3000 BC, the Sumerians realized that the evening star and the morning star were a single entity which moved differently from the other stars. This was Venus, the second planet from the Sun. Later, the Babylonians recorded and predicted the movements of more planets. It was the beginnings of a scientific approach to astronomy. Parallel to man's developing knowledge of the stars was our desire to be free from the bonds of gravity. In Greek mythology, Daedalus built wings of wax and feathers for he and his son Icarus to fly from imprisonment. Overpowered by the thrill of flight, Icarus flew to Helios, the sun god, melting his wings wax to his demise. As time moved on, the Chinese developed gunpowder and learned how to send fire into the sky, lighting up the darkest night. But sending ourselves into the sky, well, that was still a faraway dream. In the early 1500s, during the Renaissance, one of our greatest minds, Leonardo da Vinci, looked to nature for examples of how to fly, hoping to reproduce them mechanically. But people would first take to the air without wings. In 1783, a hot air balloon made by the Montgolfier brothers lifted humans off the Earth for the first time. In the early days of the 20th century, the Wright brothers pushed aviation into the modern era with their epic first flight of a powered aircraft. The demands of World War I accelerated innovation, creating specialized aircraft at a rapid pace. As winged aircraft leaped ahead technologically, a similar renaissance was developing in the field of rocketry. Even before World War I, Robert H. Goddard had been testing rockets in the United States. In Germany, Hermann Oberth was also working on rockets, assisted by Werner von Braun. On March 16, 1926, Goddard had successfully launched the first liquid-fueled rocket. During World War II, von Braun would lead Nazi engineers to develop the V-2 rocket, which would become the first man-made object to enter low Earth orbit in October of 1942. After the war, the militaries of the United States and the Soviet Union each recruited teams of scientists and engineers to develop their own rocket programs. The American side was led by von Braun himself. The Soviets employed Sergei Korolev, who had previously made major advancements in rocket technologies. But both dreamed of a bigger purpose for their rockets, to bring them to space, to walk on the moon. Each side progressed through a series of increasingly powerful rockets. But while the U.S. was still launching suborbital test flights with the Jupiter-C, the Soviets leaped ahead with the much larger R-7, the first intercontinental ballistic missile. In October 1957, Americans were shocked to hear the first transmission from space, broadcast by rival Soviet Sputnik 1 satellite. This revolutionary broadcast was transmitted by nothing more than a radio transmitter. Solidifying their power, the Soviets launched Sputnik 2, carrying its first live passenger, a dog named Laika. Americans knew they had officially fallen behind. Then the USSR did the unprecedented, sending Soviet Yuri Gagarin into space and amazing the world.
Yuri Gagarin, the one that we take picture.
In response to the Soviets' advancements, the United States set its sights on the moon, igniting a race of unprecedented developments.
We set sail on this new scene because there is new knowledge to be gained and new right to be won. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept.
United States.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Apollo 11, Houston, we are go for undocking, over. Roger the deck.
Sending a message to the world, the United States landed Apollo 11 and its men on the edge of the Sea of Tranquility on July 20th, 1969.
That's one small step for man, one giant leap for mankind.
The Apollo 11 landing immediately inspired the lives and dreams for all mankind, as millions of people around the world listened and watched together in awe as Neil Armstrong accomplished his famed mission. After his spacewalk, Neil Armstrong completed one more meaningful mission before returning home to Earth, leaving behind a memorial honoring all pioneers who lost their lives in their quest to the moon. The Americans may have won the race to the moon, but this act of remembrance was for all humanity. After the Apollo moon landing, the Russians focused their attention on space stations, launching Salyut 1, the first ever space station. The Salyut program continued for a couple of decades, with each new station pursuing various scientific or military objectives. Skylab, America's first space station, hosted only 3 manned missions in 9 months of operation, during which numerous scientific experiments were performed. Unfortunate delays in the Space Shuttle program derailed plans to boost Skylab's orbit. The station burned up upon re-entry in July 1979. Former rivals put aside their differences with the Apollo-Soyuz test project. An Apollo and Soyuz spacecraft docked with a special module allowing astronauts and cosmonauts to cross between ships and cultures, symbolizing the end of the space race. Beyond the moon, a distant red planet was now in our horizon. Focused on new discoveries, Mariner 9 became the first spacecraft to orbit another planet. Soon after Mariner 9, Voyager 1 and Voyager 2 probes set out to give us our first detailed look of the moons and rings of outer planets. Beyond the pure science, we discovered that awesome natural beauty was not limited to our home planet. After finishing their missions, these probes continue to travel deeper into space to roam the galaxy forever. Throughout the Apollo missions, NASA had been developing the idea of a reusable spaceplane. As Apollo wound down, work on the Space Shuttle program ramped up.
10, 9, 8, 7, 6, 5. All 3 engines up and burning. 2, 1, 0, and liftoff.
While the United States pursued the Space Shuttle program, Russia developed Space Station Mir, launching it in 1986. Over the next decade, it hosted more than 100 astronauts from various countries, starting a new era of international cooperation in space. In 1995, Space Shuttle Atlantis docked with Mir. The Shuttle Mir program allowed American crews to perform long-term missions aboard the station. Construction of the International Space Station began in 1998 as the Mir station reached its end.
Okay, attitude, roll 25.10, pitch 64.18, you are 10.28, rate, punt 002, negative 001, punt 002.
The International Space Station, a joint venture between nations, has been constantly crewed since November 2000, providing the opportunity to study the physical and psychological effects of long-term missions in space. It houses numerous other experiments while encouraging education programs and international cooperation. It also provides the best seat in the house for observing and studying our beautiful home planet. Like the Apollo moon landing before it, the Hubble Space Telescope inspired a new generation of young minds, opening their eyes to the wonders of deep space. After 135 missions over 3 decades and enduring the loss of shuttles Challenger and Columbia and their crews, the Space Shuttle program headed home for good in July 2011. NASA no longer had its own transport. It was a turning point in the U.S. space program.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And launch.
And launch.
After the Space Shuttle program was retired, many wondered, what's next for space? Turns out, quite a lot. The ending of the shuttle era helped give exciting life to the private space sector. Working with NASA, SpaceX took the lead in reviving America's ability to launch cargo and eventually cruise into orbit. More and more companies entered this exciting new industry, leading government agencies to focus their energies on exploration. Destination number 1. Mars. Putting people on the surface of Mars is the next logical step. Several robotic landers and rovers have already been sent there. As exciting and educational as the discoveries from these rolling laboratories have been, even small obstacles can take down the most high-tech robots. There are some things that only a human landing party can accomplish. As the private sector takes over low Earth orbit flights, NASA can now focus beyond Earth orbit, starting with its extremely powerful Space Launch System. Along with the new launch system, a new reusable crew module was also developed, Orion, conceived with the capability to fly lunar missions, visit near-Earth asteroids, and eventually go to Mars. During the conception of the Constellation program, the lunar landing module Altair was devised to take us back to the moon. While Orion is still moving forward, the resources for the lunar lander have been reallocated to other programs. A redesigned Mars or lunar lander, perhaps developed with private and international partnerships, remains to be unveiled. The spacecraft NASA designs to take humans to Mars may have a new propulsion system. One concept is the nuclear thermal rocket. Unlike the roaring flames of chemical rockets, a nuclear thermal rocket uses a nuclear reactor to superheat liquid hydrogen. Once on Mars, a basic Mars transfer spacecraft will feature an Orion module, a lander, a long-term crew habitat, and the nuclear thermal rocket. Even as NASA eyes Mars, activity in low Earth orbit will continue to increase, starting with China's Tianyong-2 space station in 2016 and Tianyong-3 in 2022, around the time the International Space Station is scheduled to retire.
Wait, 2022? Walang buhay.
Later on.
So they already planned this?
Yes.
With NASA focused on Mars, Bigelow Aerospace looks to develop expandable station modules to be used on the ISS, as well as commercial space habitats. Inflating material around a rigid core creates more interior space than in the International Space Station. Kevlar and other high-tech materials will also protect it better against space debris and micrometeoroids than a traditional metal station. Working together, Bigelow Aerospace and SpaceX provide transportation and destination for scientific or private space travel. Russia's Orbital Technologies is creating a space hotel, hoping to appeal to adventurous and wealthy vacationers.
With vacation.
Yeah.
Space Adventures Company, the only private organization to launch civilians into space, plans to send 2 tourists and a Russian cosmonaut pilot on a 17-day trip around the moon.
17 days.
Passengers will see the moon up close and breathtaking views of the Earth rising over the horizon, a sight only 24 astronauts have experienced.
Wow. It's amazing.
As commercial interest soars, permanent lunar bases can become low-gravity research stations, mining bases, hotels for off-planet vacations, and even aid man in reaching deeper into our solar system. Near-Earth asteroids could prove to be an even richer source of rare elements than the moon. Planetary Resources and its team of industry-leading experts ranging from NASA astronauts to filmmaker James Cameron is creating the technology necessary for asteroid mining. Extracted resources could then be used to further develop space infrastructure and exploration. This kind of reinvestment of resources is necessary for the continued human exploration of the solar system. What if getting to space was as easy as hopping a cab to the airport? Space elevators, anchored to Earth and an orbiting space platform, offer just such a possibility. aboard the station, spacecraft will ferry people and cargo to their destination. Speaking of borrowing ideas from the past, solar sails will prove a very effective mode of travel. The sails need to span a vast distance in order to collect the solar energy needed to push them forward. This one is about the size of a small moon. We've essentially harnessed a form of wind in windless space. With a passion to go deeper into space, it's space's sheer vastness that becomes our biggest hurdle. Earth is approximately 93 million miles from the Sun, or 1 astronomical unit. Neptune is 30 astronomical units from the Sun, or 2.8 billion miles.
2.8 billion miles. Gosh, so far.
Voyager 1 is over 130 astronomical units, but it's taken 4 decades to get there. Clearly, the space program needs faster ships.
To reach Neptune.
As humans look deeper into the stars, the idea of interstellar travel seems to be more within our grasp. It is estimated that there are tens of billions of solar systems in our galaxy, each with the possibility of Earth-like planets. Interstellar travel will be no easy feat. Drastic new technologies will be needed. Some we are exploring now, others will come as new discoveries are made. Way back in the 1970s, the British Interplanetary Society designed Daedalus, an unmanned, 2-stage interstellar probe to be built in orbit and powered by a nuclear pulse rocket. In theory, the second stage would reach 80 million miles per hour. By comparison, that far-traveling Voyager 1 is inching along at only 38,000 miles per hour.
38,000 miles per hour. It is 75,000 kilometers per hour.
As man takes to space, building stations on the moon and Mars, harnessing resources, we will still realize that we are not at the summit of space, but at the base of a new mountain. Based on the pioneering concepts of scientists J.D. Bernal and others, physicist Gerard K. O'Neill envisioned giant cylindrical colonies built within asteroids, allowing us to exploit their mineral resources while providing protection against radiation and impacts. Outfitted with a propulsion system, the entire colony could then be used for multi-generational interstellar travel. But what if traveling to other planets wouldn't take so long? What if there was a loophole in Einstein's theory of special relativity that states that nothing can travel faster than light? Inspired by Star Trek's warp engines, physicist Miguel Alcubierre theorized a drive that distorts space around a ship. As space expands behind and contracts in front of the ship, The entire warp bubble is carried forward, effectively moving faster than light. NASA physicist Harold White proposed modifications to the theory and
They still
continued
develop it.
researching, hoping someday to leap into space at warp speed.
They keep on trying it, so can make the space more faster. No need to wait 400 years to
For
reach
now, we
Neptune.
must remain much closer to home. Putting people on the surface of Mars is the next logical step. Humans have always pushed past their horizons. That drive sent them all over the world, across continents and oceans, and then into the cold vacuum of space.
Ito na.
We hit a momentous high stepping foot on the moon, then came back down to Earth. But the allure of the great unknown keeps calling us back. We will be back, but how far and for how long? Technological innovation and our drive to explore will continue to push us further and farther. There's always the next row of mountains, the next ocean shore, always the far horizon calling. Let's find what's next.
So it's done.